Hey, Seamus and I are here working on the PCB layout for the emergency vehicle light flasher. Welcome to Hack-A-Week. Get that cursor. So I've got a page open here in Express PCB. It's a freebie program, and they will make the PCB for you if you want. I'm not going to do that though. I'm just going to lay this out. This is the size of my perf board that I'm going to use. Got one right here. It's a Radio Shack perf board. And I use Express PCB to help me lay out where to run my little strips of solder and wire to recreate on this circuit. So I've double checked this circuit to the schematic I've drawn, and I'm going through the schematic and drawing the lines I need to connect all this stuff up. I've got a piece of drafting vellum over the top of the schematic, and as I go along I'll just mark out everything as I go. Like for instance right here off pins 1 and 8 I've got some traces where I'm going to put the 0.1 microfarad cap. So I can go ahead and take my highlighter and make a mark like that on each one of the 555s, and then I know that I've done that one. So as I go along I just mark off everything as I go with an orange marker. I need to put a transistor on the board now, and it's a BC557 little teeny transistor. It's in a TO92 configuration. So if I go up here to favorite components, we'll find it up here under semiconductor TO92. If I connect there, I've got the component place. There it is. I go up and grab the arrow key and I can move it to wherever I want on the board, and it will snap to the holes on the component. I just realized I need to rotate this transistor anti-clockwise, so if I select it, go up here to the rotate button. There we go, I've rotated it. Now I'll move it to where I want it. Just for the sake of showing you how this all works, let's go ahead and just put a trace. We'll bring it, let's see, we'll just bring it over here. And we'll take it up here and go right there with it and terminate it. Okay, that should be it. There's the schematic with all the stuff marked off, every single trace, and here it is, laid out in such a way that I can build it on one of these perf boards. Or, if I wanted to, I suppose I could make a PCB based off from this. The MOSFETs are on here now, and I took care of that little problem with the ground running through the 555. The way I did that was I added a PNP transistor right here to do some switching for me. Really simple application of a transistor as a switch. It's mounted right here, and it gets the low side from this 555 on pin 3. When it goes low, that low signal comes through this 1K potentiometer to the base. That turns on this transistor, and that allows current to flow from the positive side of my voltage rail through the collector, out the emitter, over here to the 12 volt side on pin 8 of this 555. This is what it looks like on the schematic. Here it is. There's the 1K resistor. It's going up here to pin 3. When pin 3 is off and not outputting 12 volts to run this 555 and make the other light flash, it goes low to ground, turns on, and then it sends a signal over to the other 555, which goes to the MOSFET and makes this one flash. So that's a good way to take a positive signal on a 555, utilize the fact that it goes to ground, and then turn on a MOSFET and allow the MOSFET to actually feed the ground through itself, not through the 555. That way you don't chance burning out the 555. One more thing I added here, right here, I forgot to put this in the beginning and I really wanted to. This is a 1N4002 diode. It's a good protection diode. What this will do is if I hook up the leads backwards, it won't let any voltage get into the circuit and fry it, which is what I just did 10 minutes ago when I came out here to go back to work on this thing for this video. I hooked it up backwards. It happens. And I fried this 555 and this one. I had to replace those two. Fortunately, I have extras. Point being, if I would have had that little protection diode in there, I wouldn't have done that. And since this project is going to be put together in a little box and hooked up by people on their own, it's a real good idea to have that protection diode in there on any circuit for that matter, just so that you don't fry all your hard work by making the mistake I just made and screwing up and hooking it up backwards. I used this overlay to double check the schematic when I drew it out on the PCB layout. That's what the orange line is. And then before I transfer this drawing onto my little board, I went over it one more time with a highlighter, each line one at a time, just to make real sure that everything on here matches everything on here and the circuit will work when I put all this together. There's nothing worse than soldering it all up, putting the components on, and having to troubleshoot a problem on the board after you've run all these traces like I will with copper wire, but we'll get into that next. This is the printout from the Express PCB layout. It's the top copper layer. This probably wouldn't work to send out to get a PCB built because that would be the bottom copper layer. But I do it this way so that I can simply lay it over the top of my perf board. Everything's to scale, and I can start tracing out where I want copper traces to be on the top of this board, and then I just flip it over and solder on those traces with some 22 gauge solid core copper wire. I just strip off the insulation and run the traces. So I'll lay out all of these lines first, then I'll know where my components go. I'll solder in the capacitors, the resistors, the transistor, the MOSFETs, and the dip sockets. Then I'll come back and solder in all of the traces. But first I need to trace out all of these lines onto the board. Pretty easy, just kind of flip it back and forth like this, and you can see where to draw your lines. Okay, all the traces are drawn on there. You can see when you flip it back and forth, basically, that they're where they need to be. Now I can go ahead and start putting components on the board. Let's get soldering this up. First thing I will do is put in the dip sockets for the ICs. And I can tell where they go by referencing the little drawing here. Now that we have all those in, we can go ahead and get them soldered in place. Just apply a little bit of heat to the pad, wait a minute, and then a little bit of solder, and that's it. There you go. Put the heat first, get it warmed up, then apply the solder. There's our happy little circuit working away. Let's cut the power to that. And what we'll do is just start pulling the components right off from the breadboard. Get these wires out of the way first. And as we pull them off, we will solder them up onto the perf board. Let's start out with the capacitors. We'll get the electrolytic capacitors. There's one for each 555. Get the first one inserted, which goes right there. Let's get the proper polarity going here. Okay. Sometimes you can leave these leads and bend them back onto the board if you need to run a trace and use part of what's left of the lead for your trace. On this one, I really don't have to do that. I'm just going to use the wire like I mentioned. So I'll just clip these off really close to the solder joint, and we'll move on to the next one. I've inserted the second capacitor, and here's one of those instances where I can use some of the lead to do the trace for me on the board. This needs to go all the way down here to the ground path. So if I just bend it and leave it flat on the board and then solder it along those lines. I've already got a little bit of my trace started. Well, that takes care of the 3 capacitors. Now we'll move on to all the resistors. There's some resistors that connect to pins 7 and 8 on the 555, and this one is inserted, and if I flip it over, you can see how I took advantage of those leads to just bend over right onto the pins of the 555. So I can just solder them there and bridge them right to that pin, and then there's a good solid connection there. I've got the transistor on here, right there, and the resistors are on here, and I just want to show you an example of what I was talking about earlier, how you can use some of the leads on the components to actually do the traces for you. For instance, between the base of the transistor and this resistor, I just bridged it with the existing leads I had left over. And let's see, where else did we do that? Right here I used the leads from the resistors to go over to where the MOSFET's going to mount. So you can, utilize some of those leads if they go somewhere and save yourself a little bit of work doing all of these traces. With a little patience, you can really build a lot of neat stuff on these perf boards. All of the components are on the board and they're soldered in place, and I've done all of the traces that I can with the component leads. Now it's time to pretty much do all of these black lines in copper wire on the bottom here. Everything is soldered up here, and I'm going over all of my traces one last time. This will be the 4th time I've checked everything, double checking my work. Really worth it to take the time and do this. It beats the hell out of frying some circuit and having to replace it, and that's never any fun, is it? So I'm just looking over all the traces, comparing it to the layout here, a fresh printout, using a white paint pen to white out the traces that I know are correct. And I'm almost finished. I've got the power wires connected, I've got the output wires connected. Now I'm hooking up some smaller wires for the LED monitors that will go on the box, and the wire for the variable potentiometer that will change the speed of the blinking lights. Just heat shrinking up the LED connection here. I've got 3 LEDs to monitor what's going on the board. I've got a green one here that's on the first 555, the one that does the long duration pulse, and then there's 2 other ones that monitor the other 2 555s, and it's monitoring them at the output on the MOSFETs. And it's kind of handy to have all 3. If something goes wrong, at least you can troubleshoot a little easier where the problem is. If the green one stops blinking, you know that the first 555 is at fault, and if it's the other 2, it's either the 555 or the MOSFET, more than likely the 555. Now I just need to connect up my potentiometer to this one, and then we'll connect some lights and run a test before we put it all in the box. Got the monitoring LEDs connected up, and now I'm hooking up these LEDs. These are like a 6 light LED marker light that I found at the auto parts store. They're about $9 a piece, and these will work okay. We're ready to put the 555s in, and then we'll fire it up. A couple things I wanted to mention about these. The location of pin 1. See that little dot right there on that one? Pin 1 is always going to be right here. The dot's there. Pin 1's here. 1, 2, 3, 4, 5, 6, 7, 8. And that's one way that you can identify it. Some other ones, they'll put a dot where pin 1 is. So pin 1 will be right here if you see a dot in that location. Otherwise, look for the half moon spot on the end of it. That one's from Texas Instruments, and that one is, not sure who that one's from. Can't really see it there too well. But anyway, now you know how to identify where pin 1 is. So let's get these suckers in there and see if everything's gonna work. It's that moment of truth. This is always the part where you're questioning yourself. Did I really check everything? Did I really make sure that all of my schematic was okay? And I went over it 4 times, double checking everything. So I quadruple checked my circuit and my hookup. So there's a pretty good chance that everything will work. If it doesn't work, well, you'll figure out eventually why. I make these videos and I put up these projects and build them a lot, and I'm still always excited every single time I do one of these builds when I get to the part where I'm putting it on the board and I'm actually putting everything together after I've thought about everything that I've wanted to do with the project, and I start putting a schematic together. It takes a little bit of thought to do that, and once I get all that ready, then I design a board, then I put it all on the board, and that's when it starts to come together and become a real thing. The thought in my head is now this tangible, solid thing in front of me here. And then you always, like I said, do triple and double and quadruple check everything. So here we are, ready to go. 555s are all in. They're in the proper way. I've got the little pilot LEDs over here. These LEDs are here, and without further ado, let's hit the switch and see what we get. Well, we have a little problem. We've got a blinky going on there. We don't have a blinky happening here. And we've got a steady light there. So that's a little weird. Oh well, these things happen. The first 555 isn't even functioning, and the second one is actually doing the blinky thing that it should, and the third one is just staying on steady. So I've got a bit of troubleshooting to do here. That's how it works sometimes with these things. It doesn't always work, and a lot of people email me, like in an instance like this, and they'll email me something like this. They'll say, I built your project and it doesn't work. What's wrong? And I can't tell because you know, I should hold up your mouse to the circuit so I can see it. I can't always troubleshoot it that way. I have to actually look at the circuit, and that's what I'm gonna have to do with this one. Okay, found a little error. I did not have power going from pin 8 to the voltage 12 volt rail on this particular 555. I corrected that, and it took care of the problem as far as the thing not functioning right. I've got a green light now on that first 555. That's working okay. You can see that they're blinking, and I've got, you know, a variable. I can slow it way down. See the green light? That's the first 555. Or I can speed it up. So I've got a pretty good sweep with that 20K potentiometer. However, let me slow it way down. Okay, remember on the breadboard when the two lights would flash, they went out. They went out all the way when they weren't in the phase where they were flashing. Now, I've gone over the circuit again and again here. You saw me say that I checked it like 4 times. Pretty darn sure I've got it exactly like my schematic, but I've got voltage still leaking through somewhere when they should be off. So in between the flashy thing, those lights should go out, and they're not. And here's another thing. Each one of the 555s, the little resistor between pin 8 and 7 is getting really warm, like it's carrying a load. Especially on the first 555. That's a little weird. I didn't have anything like that on the breadboard either. Breadboards can do some strange thing because of capacitance in them, but I don't know, I still may have a little error somewhere. So this is the schematic, and I'm gonna post a picture of this on my webpage, www.hackaweek.com. This week's hack, it'll be the DIY emergency vehicle flasher part 2. And anybody out there that's an electronics techie type person, take a look at this, look it over, and theorize. What do you think? What is going on as to why those lights aren't going out the way they were on the breadboard? There's still some voltage getting to them somehow. There's a ground getting to them somewhere, because I'm switching the ground through the MOSFETs, but something's still leaking through someplace. I'm suspecting something's up with that first 555 on my board, because it's getting really warm. So I'm going to go back over this throughout the week, play around a little bit with it, and see if I can find where I made an error. It's not too uncommon. It happens when I put stuff on a board. A lot of times it doesn't always work right away. And the more components and the more things there are on there, the more variables there are involved. And well, that's kind of how it goes sometimes. You don't always get it to work right the first time. So there you go. Anybody that's got some input, throw it at me and see what you think. If you can come up with the answer, cool. Till next time. Making a mistake is not a bad thing. Well, I guess it's a bad thing if you work in a nuclear power plant.